Hey guys, just wanted to, for anyone who was absent, just wanted to give you a quick summary of the 2.5 notes that you missed the other day. So the top part, I've got some parent graphs of those library of functions. These are 4 graphs that you should be very, very familiar with. Get yourself familiar with if not. And also, you should be able to graph these point specific, like exactly what they look like for each of these 4. So x squared, x cubed, the absolute value, and also the square root. These are what we're going to do today is we're going to do transformations. And these are 4 graphs that we really like to do transformations, shifting left, right, up, down, stretching, and all that kind of stuff. So get very familiar with these. You can see I've got T-charts there. These are the numbers that I always plug in to these. For all of them, it's 1, 0, and -1. Those are the 3 easy ones that'll kind of get you started on the graph, except for the square root. Can't put -1 in there, obviously, but 0, 1, and 4 are 3 really good input values you can do. Now, a lot of this is review. The first section here, I talk about what happens when you add something to the end of the graph. So you've done the function and then you're adding a 2 or adding a 7 or subtracting something at the end. And that makes your graph shift up and down vertically. So here's 3 examples. This is the parent graph just to see where you're started. Here's that same parent graph with a +2. So that's going to take all these y values and it's going to make them 2 bigger. And that's why the graph gets shifted up 2. Okay, whereas this one I went down 2, I subtracted 2, so that's going to make the graph shift down 2. So adding or subtracting after the function, that's going to make it shift vertically. Okay, and if at any time you need to pause, you need to get caught up on the notes and then hit play, and then we'll move on to the next one. Okay, if you add or subtract something inside the function, so this is an example of x cubed, and this is x minus 3 cubed. So this minus 3 is happening inside the function. That's going to make your graph shift horizontally, either left or right. Now, if you look up here, it says f of x minus h. That minus is part of this little formula here. So the h is the thing that's going to shift. So if you see x minus 3, the h value is actually a +3. So this is going to shift right. And that's what I am showing right here with this graph. A lot of students just know that when something is happening inside the function, you just do the opposite of what you see. So if you see a -3, you're going to shift not in the minus direction, but in the positive direction. So you're going to go right 3. Okay, so these are just 3 examples. I graphed each of them, starting with the parent graph. Then you could see the one that shifted right 3, and then the other one's going to shift left 2. And then I just drew the exact same graph after that shift. I took the origin and I just shifted it 1, 2, and then I just drew my normal little S curve. Okay. Then on the next page, we started stretching. So if you take a function and you multiply it by something, so there's a number that's out front. So this is an absolute value. I drew an absolute value. This is example A. This is the normal absolute value. And then I put everything else on top of it so you could kind of see what's happening. Okay, and I labeled it. This is A. So there's absolute value. And then 3 times the absolute value. So you're taking the absolute value, but then you're taking that answer, which would be your normal y value, and you're multiplying it by 3. So all your y values, so this y value of 1 on the normal one is now a y value of 3. And this next one, this would be the 0.22 on the normal absolute value, that's now going to be 2.6. It's going to get stretched up. So that's what happens when you multiply something on the outside of the function. Whenever you do something on the outside, if you add something to the outside, it shifts it vertically. If you multiply something to the outside, it stretches it vertically. And then here's an example where I multiplied by a fraction. So that took my graph, which was A, and it compressed it. It flattened it out. It made all the y values half what they were. Okay? And then D, if you multiply by a negative, that's going to take your graph and it's going to flip it. And again, that flip is going to is going to happen vertically. So just like it got stretched vertically or compressed vertically, this thing's going to get flipped vertically. And that's what my example D is showing here, okay? Now, again, if something happens inside the function, it's kind of the opposite of what you think is going to happen. So like our +3 or -5 or whatever kind of get shifted left to right, opposite of the number you're seeing. The same thing actually happens with if you multiply. So look at this example A. I did the square root of x. So I just came over here and plotted 0, 0, 1, 1, 4, 1. There's my square root. Okay? But what happens if you multiply by 2? Well, think about the numbers I would want to plug into that function. I would want to plug in a 0. That's good because 2 times 0 is 0 and I can take the square root of 0. No problem. But then maybe I don't want to plug in a 1 next. I want to plug in a half because think about it. If I take 1/2 times 2, I get 1. And that's a nice perfect square root. So put in a 1/2. 2 times 1/2 is now 1. The square root of 1 is 1. So there's another point. 1/2 and then up 1. So I've got this point right here. Then what's the next number I want to plug in? Well, how about a 2? Because the first thing I'm going to do with that 2 is multiply it by 2. So now I have 4. And then I'm going to take the square root of 4, which is a nice perfect square root. And I can take the square root of that again too. So I get the point over 2 up 2. Well, here's what happened. That graph, this function, when I multiplied it by 2 on the inside, it compressed the graph. So here's my normal one. This is A. And then imagine this A is getting smushed, that's a math word, towards the y-axis. Everything's getting compressed towards the y-axis. Okay, so that's what happened on B. On C, I'm dividing by 3, or I'm multiplying x by 1/3. Okay, so I'm multiplying by a fraction. That's actually going to stretch our graph out when you multiply by a fraction. Okay, because the numbers I'm wanting to put in, okay, look right here. I don't want to put the number 1 into this. I'm going to get 1/3, and I don't know what the square root of 1/3 is. But if I'm sneaky and think about it, if I plug in a 3, then 3 divided by 3 is 1, the square root of 1 is 1, and you get this nice pretty number right here. So go over 3 and up 1. So this graph is getting stretched away from the y-axis. So whatever is happening, now, if you multiply by a negative, that's going to be a horizontal flip. Okay, so multiplying a negative on the outside, that's a vertical flip. On the inside, that's horizontal flip. But as far as these two, you got to really be careful. Whatever you see, it's actually the opposite that's going to happen. If you see a whole number here, you're multiplying by a 3, you're multiplying by a 4, that's not going to stretch your graph out. It's going to compress it. If you see a fraction here, same thing. It is not going to compress your graph. It'll actually stretch it out when you see a fraction. So just remember, anything that happens inside, it's kind of the opposite of what you think is going to happen, whether you're adding, subtracting, multiplying, or dividing. Okay? Now, this is everything put together. So this is a generic function. I've got, again, I could multiply the function by something. I could add something on the end. Both of these things affect the graph vertically, either shifting it up or down or stretching it up or down. If I do something inside the function, okay, so something is happening to the x before I square it or cube it or whatever. Something's happening to the x first. That's going to affect things horizontally, okay? And it's always the opposite of what you're thinking, which is a little tricky. So take a look. Here's some examples where I kind of did multiple things at once. So here's a cube. Look at the function and then determine what is going to happen. So we went off to the side and we said, okay, we got an x cubed, so that's going to look like an S curve. But this one is going to get shifted up 2, but it's also going to get shifted right 1. So we wrote those down, and then we did that. I took a normal S curve, which goes to the origin. I shifted it right 1, up 2, and I pretended the origin's right there. There's the middle of my graph. And then I just drew a normal S curve based off that. For number 2, this is an absolute value, so I know it's going to look like a V. It's getting shifted down 3. It's going left 1. but it's also getting stretched by 2. So I took the origin, which is the bottom of the V, and I shifted it over 1, down 3. So this is the bottom of my V now. But also everything's going to get stretched vertically by 2. So a normal absolute value from this little bottom of the V normally goes over 1, up 1, over 2, up 2. But I stretched it. I went over 1 and I went up 2. Or I went over 2 and I went up 4. Okay, and so that's why this V is skinnier. On all of these, I also, and then you can look at 3, you can see everything I did there. That got shifted and also got flipped vertically, so that one was a little tricky. Okay, you were also asked to find the domain and range. So again, just look at the picture. Okay, this graph has a domain of all real numbers. There's everything going on here. But the range is just everything greater than or equal to -3. So this graph has a bottom value, and so the range is everything there and above. This is an example where we tried to go backwards. Given this graph, I wanted to create a function. So given this function, I wanted to create a function that would do these things. So right 1, down 3, and reflect across the x-axis, so a vertical flip. So we started with just x squared, and then we added things into it until we created one function that did all of those. Okay, and then the last question I have on here is just if this point, you got to think about this one. If this point is on a graph, so 3, -7, what point would we absolutely know would be on this? 2 times our function. So this is a point on some random function. We don't know anything about this function except that this one point is sitting on it. So what point would we know is on this? Well, multiplying a function by 2 on the outside is going to stretch it vertically, which means this y value of -7 is going to get stretched to -14. That's what that number on the outside is going to do to the graph, and then also to the point. And then I threw this one. Well, what about the graph of f of -x? Okay, so if you put a negative inside, that flips things horizontally. So this point, 3, 7, so right and down, so right 3 and down 7, would now be on the other side of the y-axis. So it'd be the point -3, -7. Okay, so just wanted to make this quick video kind of walking you through the notes instead of you just copying them. But again, if you ever have any questions, just send me a quick little message. All right, thanks guys.